Okay, so I just stumbled upon this tool that lets you decompile Android apps and extract all the HTTP APIs they use.
Wait, seriously? That's wild. So it takes apart APK files and finds everything from endpoints to hard-coded URLs.
Exactly, it can reveal retrofit endpoints and OK HTTP calls, which is huge for documentation and testing. But how does it even work?
Well, it uses tools like JAX and Fernflower to decompile the code. They break down the files into something understandable, right?
Right, and it can even handle obfuscated code. That's like trying to read a book with half the words scrambled.
Totally, but I wonder, how effective is the decompilation for complex apps? Does it always get everything?
Good question. I think it might struggle with heavily obfuscated code. You know, the kind that makes it nearly impossible to trace.
That makes sense. But the ability to trace call flows from activities down to HTTP calls is impressive.
I know, right? It's like following a treasure map through the app, but how reliable is the extracted information?
The evidence for that is mixed. Sometimes the extraction can miss important details, or they might be hard to interpret.
Yeah, and it could lead to misunderstandings when trying to reproduce API calls without original source code.
Exactly. And I wonder about the ethical implications of using such a tool. There's a fine line, right?
For sure, it's meant for security research and authorized testing, but what about misuse?
That's a big concern. Unauthorized reverse engineering can definitely violate intellectual property laws.
And yet, it could be invaluable for education or security analysis. It's a double-edged sword.
Right, there's potential for good, but also a risk of abuse. So how does someone even use this tool?
You can run a simple slash command in Claude Code to decompile an APK. It's super straightforward.
Nice, but what if they want to do more complex analysis, like comparing different decompilation outputs?
Great point. They can run both JAX and Fernflower side by side, which could help clarify things.
That's a smart way to tackle the complexities, but I still wonder how accurate both methods are.
Yeah, I think it varies. Some apps might yield better results with one method over the other.
And then there's the installation process. Do they need some prerequisites?
Totally, they need Java JDK 17 or higher and tools like JAX to get started, but that's not too complicated.
True, once it's set up, the natural language commands make it user-friendly.
Yeah, you can say things like decompile this APK and it gets to work. It feels very intuitive.
That makes it accessible even for those who aren't super tech-savvy. But what's the catch?
Well, it requires some knowledge of the tools and terms used in reverse engineering. That might be a barrier.
True, and it also raises questions about how much training users need to effectively use it.
Right and misuse could happen, so proper education about ethics is essential.
I agree. It's a tool that could lead to amazing insights or serious legal trouble.
So in summary, this decompilation skill is super powerful but comes with its own set of challenges.
Exactly. It's like a Swiss Army knife for reverse engineering, but you need to know when to use each tool.
And how to use them responsibly. It's fascinating how technology keeps evolving.
For sure, I'm left wondering how many more applications of this skill we'll see in the future.
Same here, it's going to be interesting to see how developers and researchers adapt to these tools.
And how they balance innovation with ethics. That's a conversation we need to keep having.
Definitely, it leaves us with so much to consider moving forward. What a wild journey.
Absolutely. I can't wait to see where this leads us next in the tech world.